Okay, let's look at this question. Find the inverse of this function. Is a reciprocal function y equal to 1 over x plus 1 and equal to f of x because f of x and y are the same. We're going to use the algebraic method, and then we may want to graph that as well, but let's look at it algebraically. So the first thing we need to do, we need to switch x and y. So here we have x equals to 1 over y plus 1. So that's the first thing we're going to do. We're going to switch x for y and y for x, and then rewrite this equation for y. So now multiply both sides by the lowest common denominator. We get x times y plus 1 is equal to 1. Okay, then multiply xy plus x equals to 1. We get xy equals to 1 minus x, and then y equals to 1 minus x over x. But we can simplify that. That becomes 1 over x minus 1, because we just break that up. The final answer, the way we write it in terms of notation, we write it as f inverse of x. The inverse of the original function is equal to 1 over x minus 1. And that is our equation. Very simple. Now let's look at it graphically. Okay, I'm using Desmos, and here is the original function y equal to 1 over x plus 1, and when you plug that in, that's what you will get. Then I have punched in the inverse function. Now the Desmos doesn't accept the inverse notation function, so I have to actually come up with another function, but I called it y, but you can call it g if you want. It doesn't really matter, but here it is. So that is the inverse of the original, and look what happens when I click on that, and here it is. Now if you notice this graph, if you take points, all the points on the original graph, doesn't matter what points they are, like if you choose a point right there, let's see if I can get that 0 1. Very good. Now the point 1 0 must be on this graph, and is it? Sure it is. It's right here. Okay, so that's 1 0, and you can actually map every single point on the original graph, switch the xy coordinate, and it will map on the blue graph the inverse, and that is a guarantee. And for the simplicity's sake, I did draw or wrote down the equation of the reflective axis, which is y equal to x. But remember, so that's a green one. This doesn't really, you can't see, shouldn't be seeing that. This is supposed to be a dotted line, straight. It's just the invisible boundary that the original graph flips over on this axis. But I just wrote it down or drew it so that you can see that it is flipped over. And when you flip over, that's exactly what you're going to get. All right, so that's the end of this lesson. Practice, practice, practice.